Hello, today is December 15th and it's around just after 1:30 in the morning, Dallas Central Time. And I'm about to give a keynote address at a conference, IEEE IoT, SMS, and SNAMS. And that's going to be in Paris, or it's held actually virtually, but it would have been in Paris. And that would have been at 10 o'clock Paris time. So I've got a couple of hours, about 1.5 hours. So I thought I will record this video presentation. It is the panel presentation I gave at the IEEE Services Congress 2020. And that was held in Beijing, China. And that was on October sometime in the middle of October 2020. And that's the big conference, Services Congress, which includes cloud computing, services computing, and some other conferences as well. So the reason I wanted to record this presentation was because it sort of ties in security, artificial intelligence, social media with services computing. Now, there was also a plenary panel last year, which is in July 2019 in Milano, Italy. And I was the chair of the panel, also a plenary panel on services computing. Unfortunately, I could not attend that panel because I had some unexpected sort of projects that I had to finish, and so I could not attend. However, I recorded the presentation, and so that was played, and we had a very distinguished set of panelists, and that was last year in 2019. So my talk for the 2020 panel sort of evolves from the panel position that I presented in 2019. Okay, so again, Services Congress is the IEEE Services Congress is the premier conference on services computing that includes web services, cloud computing, I think also IoT, edge computing. It used to also have a big data component, so it was multiple conferences put together, co-located. And so my panel position sort of overlaps, sort of cuts across all these conferences. Okay, so what I'm going to do now is share my screen and got it all ready. Let's see, okay. Services Computing Panel, it was October 2020. I believe it was around, 20th, 21st. So, integrating machine learning and cybersecurity services, and the application is Internet of Transportation System. So this is sort of my current research. I work at the intersection of cybersecurity and data science and apply it to areas like social media and Internet of Transportation. And so services computing is at the heart of what we are doing here, because Internet of Transportation Systems, security and machine learning are provided as services. Similarly for social media, right, security and machine learning provided as services. So that is sort of the theme for my presentation. And so first I'm going to talk about privacy-aware, policy-based data management. And again, services is crucial here. And then machine learning services for cybersecurity, cybersecurity services for machine learning, and then application is the Internet of Transportation Systems and role of the cloud. And so I would like to thank our sponsors and also a number of our colleagues, my colleagues, and a former PhD student who is Dr. Raul Quinones, and our project coordinator. So this area, I've given a number of keynote presentations and various other presentations, but again, the focus here is on services. And for those who attended the conference and the panel, right, they are sort of fairly familiar with services. And again, the focus is on web services. So there is a service provider who will register its services, service descriptions with a directory. And then the service consumer will check the directory, and the directory will direct the service consumer to the services. So it could be, say, a particular airline or a particular hotel to make reservations. And so the services, then the service provider would provide the services. So you've got service composition. So if you make reservations for the air reservations, then the airline company would contact the hotel company and provide the hotel services. So it'll compose all these services and provide sort of a composed service to the consumer. So that's the basic idea. And whatever we are doing, right, we are living in a service oriented world, right? So that's sort of the crux of the argument. Because, for example, we go to the physician. The physician works, say, at a clinic or a hospital. So hospital is the service provider. The physician is providing the service to the hospital. That's a third party. And we are obtaining the service from the hospital. So that's the whole paradigm. Okay, so privacy-aware, policy-based data management services. So what we are saying here for the privacy, you have the health information, fitness data, location data, social media data, image, and other sources. We collect all of this in the smartphone, data collection, data storage, data analytics, data sharing. Why is this important? There is this quantified self-movement that psychologists and sociologists are working. So you collect as much information as possible to give directions and help the human. Wouldn't it be great if I go to the refrigerator and open it? I love chocolates and vanilla ice cream, right? Chocolate cake, anything to do with chocolates and vanilla ice cream. But wouldn't it be great if the refrigerator would tell me, look, you're not supposed to eat chocolates, right? So all of the information would have been gathered about me. Imagine what that's going to do to my privacy. And again, you cannot store all of the data in here. So some of the data stored in the cloud storage, and then cloud can provide various services for this quantified privacy-aware quantified self-manager. And so our focus here is policy. So policies guide the data collection, data storage and access, data analytics, and data sharing. So policy guides the data collection services. So data collection is provided, you can provide it as a set of services. Similarly, data storage and access. So there is a data storage service, data analytics, and data sharing. So all of these services are composed and it'll provide you with a privacy-aware quantified self-manager service. In the meantime, there is a cloud storage will provide some storage services. Other cloud will provide cloud-based services to query and get various pieces of information. But again, all of these functions are implemented as a collection of services. And these services are web services because we are doing everything on the web. So our whole premise again is that policies guide the entire process. So I want to talk a little bit about the content here. So this is our a smartphone that we are collecting mobile apps and data access framework, local quality of service data store, and then, quantified self data store. And then you have the cloud-based encrypted data store with data queries and results and some mobile device. So as more data is collected, storage on the device will not be sufficient. So some of the data will have to be pushed to the cloud. And based on the various policies like access control policies, local apps running on the device will be given access to some of the collected data. And when needed, these apps will be allowed to access some of the encrypted data stored in a cloud via a simple query service. In some cases, the data may not need to be in fine-grained form, right? For a 20-year-old person, you don't have to weigh the person every day. But for a 70-year-old person, the situation is different. You would want to weigh daily or take the blood pressure daily and so on. In other cases, the data may have to be deleted to preserve privacy, right? Or generate some fake location because you don't want to tell people where you are, right? So if you're driving a car and you don't want your location to be known, and let's say you are a smoker and you don't want other cameras to catch, you smoking and send a picture to your insurance company so your premiums will skyrocket. And so the whole idea is to provide privacy-aware, policy-based services. The policies have to guide what information to collect and so on. We envision that data sharing and analytics also will be carried out as services, possibly in the cloud. And again, based on different scenarios, some of the data could be sent without any modifications, like heart rate and so on. And some other data, you may want to randomize it or mask the data, right? So again, everything is depending on policies, and all of the functions are offered as a collection of services, and some of these services could be composed. Okay. So another area that I presented at this panel was machine learning services, right? How do you provide, what sort of machine learning services do you provide for various cybersecurity applications? So typically what you do is you use past data to build a classification model, predict the label of future instances using the model, and that will help with decision making. So you are having massive amounts of data, especially for applications like financial applications, or you can have network traffic to analyze the network for any security violations, for any anomalies or insider threats, or even for COVID, a lot of tracking and tracing data, trace and testing all of the data coming as streams. So continuous flow of data are very common in our connected digital world, massive amounts of data. So as you collect the data, you build the models to understand the concepts. So in a financial world today, it will be by Microsoft. Tomorrow, it's going to be by Apple, then by Facebook, then by Google, by Amazon. The concepts are changing, right? So you have to capture those changes. So one model, like back 20 years ago, we used to develop just one classification model. No, that will not work. So constantly, you've got to keep on building models. So what we do is build an ensemble of models, a collection of models. From time to time, these models will talk to each other and then throw away the models that are no longer valid, sort of old, outdated models. So that's the challenge. So all of these models will have to work with each other, perhaps with the human in the loop. And then when new data comes in, the models will work on the new data. If it's, of course, you train, and then new data comes for testing. If it's attack, you block and quarantine. If not benign, you store it in a server. Okay, so we applied this to insider threat detection, a number of other applications. So you collect data like system calls and so on, and then you have the I chunks, you gather data, and then build the ensemble of models. So feature extraction, we use supervised learning, support vector machine, and one class support vector machine, and also unsupervised learning, which is graph-based anomaly detection. And we built an ensemble of models. Time to time, the models are checked and they are thrown away, right? Ensemble-based stream analytics. And so then when the I+1 chunk comes in, it tests. And then, of course, if it's an anomaly, you quarantine. And then you, of course, do an investigation. If not, you store it in a server. So this worked really well for us for insider threats. What are insider threats? Bad people can be in a company and pretend to be good. So in a system, you can have, again, bad people, or you can have processes that could be really malicious. It could be part of a application, or it could be part of a database or an operating system or a network or applications, whatever, an email application. So they are bad, malicious, but they pretend to be good. You will not suspect, right? But they are maliciously waiting. And then when they get the opportunity, they will, try to invade or try to gather secrets and send it to the perpetrator. So that's what insider threat is all about. Okay, so again, our data mining or data machine learning, data science is provided, or machine learning, as a collection of services. And these services could be, what we are assuming is web services. Okay, so the other challenge is one of the hottest areas, right? Most popular area in cybersecurity, and that is cybersecurity services for machine learning, and that's adversarial machine learning. So what's the problem? Adversary is trying to learn as much as possible from us. It's modifying data to defeat the learning algorithm. So they will try to figure out what is our learning algorithm. Okay, what is the data that we are using? and then it's going to modify its behavior. So we've got to understand the adversarial learning process. It's not concept drift, it's not online learning. Adversary adapts to avoid being detected. During training time, there could be data poisoning. During testing time, modifying features when data mining is deployed. So there's a game being played between us and the adversary. So look what happens here. The red squares are the bad instances and the blue circles are the good instances. And this is the support vector machine boundary. See what happens. Adversary is now watching, learning all what we are doing, and it's trying to push the bad instances, pretending to be good instances, and it will not get caught. So what do we do? With some extensive mathematical computations and using game theory methods, we try to push the support vector machine boundary. So the red crosses are the bad instances and the green circles are the good instances. So black dashed line is a standard support vector machine classification boundary, and the blue line is the adversarial classification boundary. So we move the dashed line to this blue line. Okay, so when we move it, a lot of these red crosses, right, will be caught because they are bad. Similarly here, all these black crosses that you see, they are bad and they are being caught. But not everything. What goes beyond this blue line will be treated as good instances, but still you can see a lot of the bad instances have been caught. So the question you can ask is, why not move this blue line right here? So if we move this blue line, then we can catch as many bad instances as we can. But the problem is that the green circles, right, will be considered to be bad instances, and you don't want that. You do not want false positives, and you don't want false negatives. Right? So that is the challenge. And again, this whole adversarial machine learning, right? It's offered as a collection of services, right? When you apply machine learning. So, and then how do you learn from the adversary and so on? So that is security services for machine learning algorithms. So that's the point here. Okay, now how do we apply all of this to IoT? And by IoT is Internet of Things, right? So our cell phones are connected to our refrigerators, are connected to our radios, and connected to our televisions and our computers, and everything is connected, right? So we apply that. That's Internet of Things. Internet of Medical Things is all the medical equipment are connected in a hospital. Internet of Transportation, you can see all the cars are connected. The cars are connected to trains, trucks are connected to roadworks. And so by having this connected transportation system, it really helps with respect to accidents, with respect to directions, and so on, right? Reducing the speed. So that is really what the whole future is going to be based on Internet of Things, right? So it's an aggregation of stuff like Internet of Transportation, Internet of Medical Things. It's a collection of computers and networks and your smartphones and all the microprocessors, tiny sensors, and the cloud and the edge. So everything is involved here. Okay, so imagine the privacy, right? So instead of a smartphone, or what we have is a car. Instead of healthcare data, social media data, we got radar, we got GPS, cameras, LIDAR, ultrasonic sensors. All of that is going into this, maybe some small gadget inside this car. So you have data collection, storage, analytics, and then encrypted data, like I showed earlier, goes to cloud storage, anonymized data, cloud-based services. So it's a privacy-aware, policy-based autonomous vehicles. And what our position, we haven't done this work though, okay? The earlier work with our smartphones, that's our current project, but this is the future. And so what we are saying is we have data collection, data storage, data analytic, data sharing, all of that is provided as services. And in fact, with Internet of Transportation, we've done some work on security for Internet of Transportation and looked at privacy, but this is sort of the future, right? Because we don't want people to find out where we are and so on. Okay, so my last chart, and again, I've used some of these, I've given several presentations, detailed presentations on what I'm talking here. So this was already a panel position. So I'm taking some of the essential things that the work I've done and focused on the services. So what is a role-based, cloud-based services, right? So what we are saying is cloud can provide this information sharing. How can it provide? So you have an agency 1, agency 2, agency 3, or autonomous vehicle 1, autonomous vehicle 2, autonomous vehicle 3. And then we built this entire cloud. Our cloud was based on the Hadoop MapReduce framework, and we built this policy assured information sharing. Assured means secure, policy-based information sharing. That's the, with semantic web, based on the semantic web framework. That's the Tim Berners-Lee's framework, the next generation web. So that's a policy manager. And so we have different organizations, agencies, or cars dumping all of the data and the policies in the cloud. Cloud could be anywhere. It could be multiple clouds. And then policies guide the sharing. So we had our demonstration system had some toy policies. So like agency 1 tells agency 2, or like, okay, I will tell you a secret. Like I tell John a secret, but don't tell the secret to Mary. But these are toy policies, TO1, children's policies. So we are working with some policy experts to come up with some real world policies. Okay, so again, each organization will store all of the data and the policies in the cloud. And then when they share data, right, they have to, the cloud will determine what data should be shared according to the policies that have been developed. And the policies could be dynamic. So again, this whole environment, our implementation, we did multiple implementations. One was on Hive-based policy management. Hive is the Facebook relational big data, relational data store. And the other one is semantic web-based data. And so that was sort of the implementation that we carried out. And that's where the cloud comes in. And this is really, the cloud is what I'm saying, the cloud-based services. Some of the services could be provided by the cloud. And so again, the contact, as I said, Alvaro Cardenas and Raul Quinones. Alvaro, we worked on the Internet of Transportation, Murad Kantarjalu on the adversarial machine learning, and Latifa Khan on machine learning for cybersecurity, and Rhonda Walls is our project coordinator. Okay, so I'm going to stop sharing. And so again, the whole idea here is that I talked about security, integrating cybersecurity and AI with respect to privacy, as well as cybersecurity for, machine learning for cybersecurity, such as insider threat detection, intrusion detection, malware analysis. And the other part was what happens if these machine learning techniques are attacked? So what about cybersecurity for machine learning, right? And then where do services come in? So everything is rooted on services because we are living in a service-oriented world. And then I explained to you earlier, this whole paradigm of web services, right? Service consumer wants some service, will go to the directory, it will provide the information where to go. It's like yellow pages. And the service provider will register with a directory. And then the service consumer will go and ask the service provider, give me the service. Of course, all the security policies will have to be checked, and the service provider will provide the service. Sometimes the service has to be composed from, say, airlines, hotels, cars, all of that is composed, and the service provider will provide a bundle of services. And so that's where we are going. So even sort of teaching, right, in a class, so the teacher, the professor is providing a service to the university, and the students are consuming the service from the university. So the third-party framework, and the professor is using the framework, the university, to provide the service consumer, the students. So again, these days we are working remotely, right? We are all having online classes and so on. So it's really truly a service-oriented system because we are using e-learning and Microsoft Teams to provide all the services. And so it's underneath all of that is the service-oriented architecture. If you have a two-person, like when I used to go in-person class, yes, we are using computers, but computers are not used to provide these services. We are not using the service-oriented paradigm to a great extent. Of course, e-learning, is based on services, but then we are presenting the lectures with PowerPoint and so on. But now we are using, again, we are sharing screens, so that's information sharing, right? And then we have, there is, again, the whole service-oriented paradigm with Microsoft Teams or with Zoom or with e-learning. So that's the world that we are living. So more and more we can see these web services, and I call it web services because everything is based on, right, web these days. And again, the cloud is also a collection of services, right? Cloud could be platform as a service. So we are infrastructure, right? We get all the operating system and all the machines and so on. Cloud can provide us with the platform, the programming support environment, the databases, and the cloud can provide us with the applications to compute our taxes and whatever services it can provide. But it can also provide data, right? If you need data for our experiments, rather than paying and getting the data, we can, subscribe, and the cloud can provide us with the data. So cloud can provide infrastructure as a service, platform as a service, software as a service, software/applications as a service, or data as a service. So that's based on the service-oriented paradigm. Of course, there are a number of security frameworks like XACML, Extensible Access Control Markup Language, and SAML. SAML is Service Security Assertion Markup Language for identification and authentication. XACML provides access control. It's based on the attribute-based access control. So that's what goes underneath, right? When you're providing cybersecurity services or privacy services or machine learning services. So that was my panel position. And again, I didn't have I took about almost 25 minutes for this presentation, but I think my panel presentation was only about 10 minutes. So it was a kind of a rush. So I decided to explain very clearly how you bring the service-oriented paradigm, the cloud computing with AI and cybersecurity, right? So again, thank you very much for listening. And again, stay tuned for more discussions and more videos. And I'm going to put this on YouTube. Again, thank you. And I'm going to end this presentation.